Hello everyone and welcome back to the Victoria Game Engine series. This is episode 8 where we will be doing our platform layer setup on Linux. So if you haven't followed the previous video and you want to see how we set the platform layer up on that, you can go back to the previous video, which should be episode 7, and you can follow up just to the point where I tell people that you can swap to the video, which I think is about 25 or so minutes in. So in terms of what we actually need to do, pretty much everything was already set up for us in the previous video. All we need to go here is you need to go and create the Linux subfolder because that wouldn't have been committed during the previous episode. And under here, we're just going to go click New File and create our logger Linux. Because like the previous video, we're going to be wanting to do something very similar. So again, pragma wants include our type defs. We're also going to want to do our preprocessor definition for Linux. So platform Linux, endif. And within here, we're going to want to include our logger. And again, this class is going to look very similar to the Windows one. So we're just going to call it a class Linux logger, public logger. We're going to have a public virtual void log v. And I'll simply copy the arguments in here as an override method. And we will have the same thing for our log error. And with these defined, we can really quickly go and create our logger Linux C source file. And in here, it's going to look very similar to our Windows file, just with a couple things taken out. So the first thing we're going to do is we're going to include logger linux.h. Again, we're going to check if we're on the Linux platform layer. And within here, we're going to want a couple other includes. We're going to want stdio, and we're going to want string.h as well. So we're going to need those for a couple functions. And speaking of those functions, the first one will now come in here. So the logv function here, if you followed the Windows video, you'll notice that it looks very similar to our main method that we use there. And the reason we do it this way is simply because by default, ANSI escape codes we are expecting to always be included in whatever platform that you're running Linux on. So there is a case to be made here that this should probably be a Unix logger rather than a Linux logger, because there are other platforms such as Android that also run off Unix-based operating systems, which will run to the same sort of std out and run the same kinds of commands. But since we're only really developing for Windows and Linux at the moment, we're going to name it in this format. And really, there's not a lot to say here. We just get a buffer. We set it all to 0. We format everything from here into that buffer. We then print that buffer to std out. And we check if it's a error or not. And it's pretty much the same as we were doing in the previous episode. Just bear in mind that that is the general format for an ANSI escape code if you did not follow that video. And as for the log error function, it's going to look pretty much the same as the other video, in that we have a console message that is unspecified that we then give a value to from one of these various sources. We then log f it to the console with a bunch of formatting already done. And here, again, just to keep up with our consistency that we want to keep, we're going to be swapping around file and function now. And that is pretty much the entirety of this logger Linux class done. There's not really a lot to it, so we can move on to our OS layer. So here under your Linux header again, you're going to want to create a new file, and we're going to call it OSLinux.h. We're going to pragma once. We're going to include our type defs, not core routines, type defs. And as you'd expect for much of this video, we'll be getting this preprocessor definition in. And then within here, we're going to, of course, include the OS. And under here, we're going to create a class OSLinux as a public OS. So our first set of functions will be as follows. You'll remember these from the Windows layer, where again, all we have is our alert class. Currently, this isn't configured properly. I'll get onto that in a moment. Again, our print functions and getting our running time and our current time as well. And then we have our other set of functions. And as many of you would have guessed, these are our initialize, run, and our constructor and destructor. And that is pretty much everything that we need in this header. So we're going to pop into here and create our source file, which we'll also fill out. So first things first, we're going to want to include the header file, of course. And we're going to do our if platform Linux. Making sure everything is formatted correctly. And within here, we're going to include a couple things. We're going to include the logger Linux, and we're going to leave some space to include the display manager. Like in our Windows OS class, we're going to want to also include the main as well. Then we're going to want a couple of header files from outside. So we're going to want to include stdarg as well. And we're also going to want to check something that should be defined on most Linux builds, but we need specifically for one header file, and that is if posix, so C source is greater than or equal to 309L. Then we include our time.h. Else we're going to throw an error. And we're just going to copy and paste a definition in here, which is this. I'm going to end if. And this is specifically something for our getting our time functions that you can only do in this way on Linux. First up is our printing functions. And I won't really bother going through most of these because you'll have seen effectively the same thing on the Windows side. But again, all of it is just getting our VA list set up, sending our arguments into our logger, which is initialized, and then ending it. And of course, our logger is held in our base OS class, so we don't need to declare it here. And then further up in the file, because in my original I had formatted these weirdly, we're also going to have our alert box. And as I kind of detail out here, which I'll go into now actually, so because of how Linux is built, there isn't actually any default message box application that we can run so that we get an error on X11 or Wayland that exists within those native APIs. However, I have done a little bit of digging, and there are ways of doing it, but it requires us executing a system path application in our OS so that we can use these properties, which is something that we will have to do in the future. But for the sake of making this video much simpler, we are simply going to stick to just having an error printed here. Unfortunately, there is nothing like that set up for Linux at the moment, but hopefully in the future we should have something that exists that can be much like MessageBox. And that simply comes because of the nature of how Linux is maintained. Everything is included when absolutely necessary rather than having a bunch of bloatware. The next couple of functions are our getting our OS running time and getting our current time, which are as follows. So the reason that we needed that time spec there is because here we need to call to get the time, and then we want to return the number of nanoseconds times by the number of real seconds multiplied by, I believe that is 10 to the 7. And that gets it in 1 microsecond rather than in nanoseconds, because again, this command says get current time usec rather than get time nanoseconds, and we don't want it every 100 nanoseconds, we want it every microseconds. And again here, it'll just call to getting the OS running time, minus the timer offset, and divide it by, again, 10 to the 7, I believe. or 10 to the 6, and that gets it in real units, so that'll be in seconds as you would expect. Next up is the OSLinux initialize function, and this one is pretty simple. All it has to do is it has to set up our system clock, so it will get the resolution of the clock so that we can get our timer frequency. We can also get the timer offset as well from that, and then it saves all the information that we need there. And of course, we're also going to want to do our void OSLinux run function. And all that's going to do is while true, if iteration, and we break. And then here we would include our display manager, but we haven't included that quite yet, so we'll leave that blank there. Then we call to our class constructor and destructor, which I can just paste in here. And all this will do is it will create our Linux logger and it will delete the subsequent Linux logger as well. And that is the OS class, well, so far set up. Next up is our display manager. And if you were following the series from the very start, I may have mentioned initially that we would be using XCB as our windowing library. However, that has changed. We are now going to be using X11 instead, rather than using XCB. Of course, if you want to go ahead and use XCB by yourself, by all means, at some point in the future, we are likely to go back and support XCB, and even at some point to go back and support Wayland as well. However, by default, we are using X11 for no preference reason other than it is more likely to be supported on all systems. So with that said, we are going to go and create our header file for this. So at some point, everything will be grouped under a X11 subfolder, but for now, we are just keeping them in one place. So under here, we're going to call this display manager x11.h, into pragma once, we're going to include our typedefs again. We're going to, again, if platform Linux, end the if. And within here, we're going to want to include a couple things. Of course, we're going to want to include our OS display manager. And we're also going to want to include our data event class as well. And of course, you're going to want to include your X11 headers. So here we go, X11 xlib.h. Now, a quick note, if you want to install X11, so say that you don't have the headers here, that if at the end of the video I hit compile and for some reason you're getting link errors, it can't find the library, you're going to want to go to your terminal and you're going to want to type in sudo apt install, you're going to want lib x11 dev, and that will install the X11 headers for you so that you can use it. And of course, if you are not running a Debian-based OS like I am, then you will use your own package manager there, or simply install them from source if you know how to do that. But under here, we're going to create the class DisplayManagerX11, a public display manager. And within here, we're going to want a couple of things. So the first thing we're going to want is we're going to want a display. That's a null pointer by default. This is, of course, the display that X11 gives you. You're also going to want a screen pointer. And you're also going to want the screen ID set to 0 by default. And all of these will make more sense later on. So next up, we are going to create our window data struct, which, if you remember from our Display Manager Windows, is effectively the same kind of thing, but on this version of the OS. I'm going to call the struct window data. You're going to give it an ID. We'll give it a window as well. Also going to give it some xset window attributes, window attributes. Also going to get an wm close atom. Also going to want an event of window notification uint 8 of notification callback. And lastly, our uint 16s of our x, y, width, and height. And that will be our basic window layout. We're also going to want then a window data pointer to our current window, which by default will be null pointer. And that is all of the variables that our display manager is going to need to keep track of at this point. So then all of our public functions will then be needed. So by now you'll be very much used to our layout if you followed the Windows video. So you'll know that first up we have our create function and destroy function. We will also have our process event, swap buffers, and finalize functions. And of course, a display manager x11 creation, and display manager x11 destruction, which you need to mark as such. And with that all out of the way, we can now head into our source file and start creating that as well. In the source file, the first thing we're of course going to be doing is including our display manager x11. Once again, if we're on the platform of Linux, this file will compile everything. Otherwise, nothing will be compiled. So here, we're going to want a couple of things. Well, first off, we're going to actually want to include our OS. And of course, we're going to want to include our, open the terminal by accident, main.h. And of course, the first thing that we will create is our create window function. So here's just the explanation of it. So then go to display manager x11, create window. And from here, we can grab all of our parameters and paste them in. For those of you that followed the Windows version, you may have been very familiar with how Windows has its window creation. It has its window class that you need to create. You then create the actual window itself. You assign some attributes, and it's relatively, there's not a lot of setup you have to do. For Linux, however, there is a little bit more that we need to do. So the first thing that we're going to do is we're actually going to create a integer. We're going to call this our value masks, or sorry, our event masks. And we're going to set it to a bunch of values. So with X11 specifically, the way it normally asks you to create a window is that you specify a bunch of different key masks that it will look for, so that when it comes to processing events, it will only ever look for specific events. What that means is that by default, X11 will not look for whether you want to close or want to close the window, whether you actually have your cursor moving, whether you've pressed input in the window, all of those things it just completely ignores. But for the sake of our video, we do actually want to be looking at these. So the first thing we're going to do is we're going to specify a bunch of flags, and rather than save the trouble of spelling them all out, I'll paste them in here. And they effectively read as following. So we look for key presses, key releases, the key map state, that simply specifies whether the key mapping on your keyboard has changed. The pointer motion, whether buttons are being pressed or released on our mouse. When the pointer enters the window, whenever the pointer leaves the window, and whenever the window is resized. Once you've created those event masks, you then want to create a structure of xSetWindowAttributes. Call this window attributes. And we're just going to set a bunch of things. So the first thing we're going to do is going to say window attributes dot border pixel is a black pixel. And this will be display screen ID. We haven't set display or screen ID yet. We'll be doing that in our initialize or our class constructor. We'll then set the window attributes background pixel to the white pixel, again, of display screen ID. Then we're going to set window attributes.event mask to equal the event masks, which is to window when equals x create simple window. And from this, we're going to pass our display, our root window from our display and its screen ID. We're going to pass the x, the y, the width, the height. We're going to pass one here, and then pass black pixel, display, screen ID. I'm going to pass white pixel, display, screen ID. And that's everything that we need in this function call. And now, normally you would use xCreateWindow, but so far I have been unable to check if some of the extra things that xCreateWindow specifies needing, such as visual info, depth, inputs, outputs, some of their value masks and so on, which are needed when we start using OpenGL. But in the current form of this function, I'm not entirely sure if we can use those as is. So we're going to be using a simple window for now. And in like next episode, we'll be moving to creating a less simple window and having more configurability. Next up, we want to create our window data struct. So win data, which equals a new window data. Could allocate, but we're using mem_new here. And we just want to set the x to be our x, the data's y to our y, the data's width to our width, and the height to our height. We are also going to make sure that our window attributes are also stored, even though we're not currently using them at the moment, because they are actually required. So all of this is set up as future-proofing, but later on, we are actually going to be using this in this function here, and we'll need to keep hold of our window attributes. But for now, we are simply going to copy our window attributes into our window data just so that we can keep store of it in case we need it at any other point. We're also then going to get our notification callback, when you can spell it. Well, that's not what you're going to do. Win data. Apologies. Notification callback dot connect notification callback and false, because we do not need to prioritize its place in the queue. We're then going to create our close atom by calling to xIntern atom of our display of type WM delete window with true. And then we're going to call xSetWM protocols with our display, with our window, with the close atom with 1. And what that'll do is that will basically mean that we are in control of closing our own window. Otherwise, it would not allow us to close. It would click on the X, it would hit Alt F4, whatever we do. The protocol simply won't allow us to do anything. But using this method, we can close our window. And of course, we're going to want to keep track of that. So we call to win data of WM close atom is our WM close atom. Then we call to xStore name of our window of pname, whatever we pass through. We then call to xClear window and then we call to xMap raised from display win And what that means is that it will clear the window, so it'll make sure that anything that's been drawn to it doesn't exist, and then we will map it. And then here, we're just going to call to win_data, win equals our window. And last but not least, we are going to set our Windows data, its ID, to equal 0. We will then tool to our window to equal our window data. And then we will return the Windows ID. And that is the basic creation of a window. There are a couple of variables here that we haven't yet set up. I didn't really go over displays, screens, and screen IDs as in much detail. And there is some stuff here that doesn't really make sense at the moment, but will make sense in the future. And I'll be sure to explain it when the time is relevant. Of course, every creation has its destruction, and we will need to create our DisplayManagerLinux destroy window, passing in our ID. So first off, if there isn't a window, so if no window has been created, then there's no point trying to destroy a window, so we just return. Then, but otherwise, if the window does exist, then it must have an ID, and if that's equal to our ID, then we need to do some destructions. First thing we're going to do is we're going to call to x destroy window, display, window, win. We're then going to call to delete on the window because all of its data will have been freed. And the window equals null pointer. Next up is our processing of events. So we're going to call to void display manager x11 process events. If there isn't a display to be found, i.e. the processing events hasn't happened yet, then we need to return, because there is no way for us to be able to query any events. Otherwise, we can do stuff. So let's call to x event. And we are then going to set up another while loop, which is while the events pending in the queue from our display exist, we will look through those events. So that means that we will call to x next event, display, passing the address of our event. And this will get us whatever event we are dealing with. Next, we will then call to the switch, and this will be where we go through our event.type. Now, there are a bunch of different event messages that we could look out for. Now, there's a bunch of messages that we could be looking for from, pressing keys, pressing buttons, releasing buttons, whatever. But there are only two real events that we want to care about. And those are the case of client messages, which we'll just break on for now. And the case of course, destruction. So case destroy notify. Again, break. You'll notice that unlike the Windows library, here we are just directly calling to the event processing. There is no window procedure. We will all have to handle the events that we want to handle by ourselves. So in the case of the client message, we will want to check if it's the event we're looking for. If it is, then we need to do something. So here we call to event.xClient.data.l 0. I want to check if it's equivalent to our close atom. So if we go to window, wm, close atom. In this case, both of them are going to have the same value, and that means that we have called to close our window. And of course, that means that we need to call to our notification callback to fire an event. Notification wm window close, and passing in our window ID. We then want to call to our OS to set the exit code to 0 because we're about to exit. We are then going to set should quit to true. And we're going to return here because otherwise the event will still keep looping through and we don't want anything to happen. And of course, with destroy notify, we are literally going to be doing the same thing. This event is called, the destroy notify is called by either ourselves through some other stuff we can do with X11 or by the software itself. But in our case, what we're doing, this is normally a message that we'll get in the first place. So therefore, we want to handle it there. And of course, we're just going to be doing the same thing as you saw above. Just once again in order, and then we'll want to return or simply break out. And with those two events, that's pretty much everything we're going to be doing in our event processing for now. Of course, later on, we will come back and do a whole bunch more. Next function that we're going to have on our list of things to do is our swapping buffers. Again, this isn't going to do anything because at the moment we haven't got any buffers to swap. That'll be coming when we have our GL manager set up. And before we move on to our class constructors, destructors, we do have one more function. That is our DisplayManager X11 finalize. And here what we're going to want to do is we're going to want to check if our window still exists, then we want to destroy it. And if our display still exists, then we want to close the connection to that display by calling to x close display. And that's effectively everything this function needs to do for now. So last but not least, we have our class construction destructor. So here, DisplayManager X11, DisplayManager X11. What we're going to need to do here is we're going to call to our display to open it. So x open display, passing null pointer. And here we're going to check an error condition null, the message. And that is because if the display is null, then we can't actually go ahead with any of our class registration. Otherwise, we want to then get our screen, which we can then get by calling to default screen of display, and the screen ID being the default screen, passing the display as well. And that's effectively everything the DisplayManager X11 needs to do in its constructor. And here we are just going to, again, do the same thing for its destructor. And here we're actually not going to have anything in here for now because there's nothing our destructor needs to do. And with that all said and done, that is actually the entirety of our very basic X11 classes written. Now we can move on to doing a little bit of testing just to make sure that everything is working. So if we go to our main.c++ and open it up, you'll see that we get a whole bunch of complaints here because it's trying to register classes that don't exist. Now, this is a problem that we will address later on. However, for now, we are simply going to just replace these with our own versions that we have created. So again, include platform Linux, DisplayManager X11 for Linux, include platform Linux, OSLinux, and change this to an OSLinux and a DisplayManager X11. And here doesn't actually need any arguments, so we can just do that. And everything looks like it's working. Now, before we actually hit compile, there is one thing that I've just remembered, and that is that when we were creating this class, we need to add a call to our display manager, which also means including it. So we're going to go here and include display manager X11. We aren't actually going to include default display manager because we are going to want a little bit more display manager functionality later on within the OS class itself. But here we call to display manager, get singleton, and we are going to call to process events. And that gives us our entire main loop. So now if you hit Control-Shift-B, you should be able to compile. And we have an error here. That is because sprintf. Well, we did have a compilation error there, and I believe that is because sprintf exists in the stdio.h file. Yep, that fixed that error. At some point, you might want to go and create our own implementation of this, but for now, we'll keep it here. That's the only other change we had to make there. So now if you hit F5 to run, we should see that we get an empty window appear with the same title, everything appearing to work just fine. Nothing really going on, but if we hit the X, you'll notice that it closes as well, and our application closes in addition to that. So that is our Linux side of the platform layer done. And what that means is that we now have a Linux and Windows implementation of the same things. So from here, it's fairly smooth sailing. The only things that we need to do now is we need to create our contexts for both Windows and Linux again. So next episode will probably end up being, so the next episode will be a ambivalent episode. So it will focus on both Windows and Linux in the same video. That video, we are going to go over creating entry points for both of the applications and their basic setup. That means that the entire process of creating our display manager, our OS, that's all kept in completely separate environments, which means that our main loop, which we can go to here, all of this won't really have this OSLinux declaration. That will exist in a separate file. The actual int main will no longer exist in this file, simply because of the way that we're going to have to do some things like argument passing, and simply just that the creation and the entry point that we have. And that's what that episode is going to be on. But of course, the episode after that, we are going to be focusing on context creation. Very likely that will also be separate videos. So we will do the Windows side, the Windows GL, WGL, and then we'll do GLX, so the X11 implementation. And then we will come together for one last video where we shall, well, we'll render a triangle. So with all of that said and done, I do hope you enjoyed this video, and I'll see you in the next one. A good bye.